Hello and welcome to our third example on using Excel to implement a simulation model. Feel free to look at the PDF or pause the video to read this question repeatedly so that you are familiar with it, but I will just read it through once. Heartbreak Hotel routinely experiences no-shows. People who make reservations for a room and don't show up during the peak season when the hotel is always full. No-shows follow the distribution shown in the table here. Okay. So we'll use that. To reduce the number of vacant rooms, the hotel overbooks 3 rooms. That is, the hotel accepts 3 more reservations than the number of rooms available. On a day when the hotel experiences fewer than 3 no-shows, there are not enough rooms for those who have reservations. The hotel's policy is to send these guests to a competing hotel down the street at Heartbreak's expense of $125. If the number of no-shows is more than 3, then the hotel has vacant rooms, resulting in an opportunity cost of $50 per room. So we want to just simulate this and then do this for 30 days and see what else they want. So we have to generate a different number of no-shows that could happen with different probabilities. And then we'll build this up slowly depending on how the no-shows compare with the overbooking that the hotel has allowed. All right, so I've laid out the basics here. Our no-shows, our probabilities, and we'll have to set this up a little bit further. The rooms that are overbooked are 3 because the hotel is always full. And then I wrote down the cost here in case they have to send people to the other hotel. They don't have space for them. And if there are a lot of no-shows, then they actually have vacant rooms, and that costs them $50 as well. All right, so we are going to have our days here. We want how many days? We want 30 days for our simulation run. We're going to generate some no-shows, which means we'll have to finish this table. And then we want to keep track of how many rooms are we short, what is the cost of that, how many rooms are vacant, what is the cost of that, and then the total cost for that day. Okay, so first we need to finish our distribution table for VLOOKUP to work correctly. So our lower limit is going to start at 0, end at 0.1. The upper limits here are going to be these probabilities added together. For example, that one will be the sum of everything up to that point. But I want to fix the first one so it doesn't move as I copy the formula. Or you can, of course, just type it in, right? Of course, I've set my formula calculation to manual, so I have to press F9 to actually perform the calculation. I'll copy this up, calculate, and then double click on random ones to see, yeah, no, it's doing what I want it to do. And then the lower limit past the first one is just the previous upper limit. Copy that down like so, recalculate always, double check a few of them. Yeah, I could visually do that as well, of course. Then I just want to copy these no-show values over to the other side for VLOOKUP to be happy. And we've done this in our previous examples. Please go and watch those first. Carefully understand those first before moving on to this one, of course. So when we want to generate a no-show value, we're going to use VLOOKUP. I have it there, or just search for it. It helps me to use the function helper thing here. The lookup value is going to be a random number that I generate. The table array is going to be from lower limit to the no-show numbers. I want to fix those because as I copy them down, that's always going to be where VLOOKUP looks up the no-show number. Index column that it should return is the third column. I can generate a few by pressing F9 on my laptop, and I see I'm generating different values in those ranges. Never get a not applicable. Everything's good. I can copy this down a little bit. See what I get here. Good. Oh, all fours. Wow, look at that. Okay. So let's copy this down maybe further. Maybe you like that. See more variety there. Okay. So now we want to figure out if we are short any rooms, because we've allowed an overbooking of 3 rooms. We have to compare that to how many people didn't show up, sometimes 5, sometimes 0, right? In the case of 5, for example, we will have more than enough space for everyone. But in the case of 0, we have overbooked 3 people and we are short, right? So what we could do is a couple of things. I'm just going to write it over here, for example, randomly. We could use an if function. That might be nice for some people, but I'll show you some options in a second. Over here should be fine. Okay, so I can compare the no-shows to the overbooked rooms. When will we have rooms? When will we be short of rooms? Well, when the rooms that we overbooked, so let's say it a different way, when the no-shows are less than the rooms we overbooked. For example, 2 in this case is less than 3, which means 2 people didn't show up, but we still have 1, and we don't have a room for that person. So we are short 1. So if that is the case, that we are short when the no-shows are less than the rooms overbooked, than are 3, then we simply need to see how many 3, or that rooms overbooked cell, minus the no-shows. And if it's false and we're not short, I'm just going to put a 0 there. We're not short any rooms. So let's see how that goes. So now if I just recalculate a few, let's see how the no-shows, if the formula compares it correctly to the rooms overbooked. So I see there, if I have 4 no-shows, then we're not short any rooms. If we 4 again, come on, give me something else. If I have 3 no-shows, then I'm not short. It's perfectly full. If I have 2 no-shows, now I still have 1 person that's overbooked and I'm going to have to move them. 3 again, 1 no-show means 2 rooms overbooked. 4, 4, 1. Of course, I'm looking at a single 1 here. I can copy this down. However, that's not going to work because I did not fix the room overbooked cell, this pink one. So I can easily spot that, go back, fix it, try again, recalculate a few times. So you see here, when I have a lot of no-shows, there's nothing short. But when I have a few no-shows, yeah, I'm short a few rooms, and that's going to be my cost. There's no reason why I couldn't have done this for the first day. I just like to do it somewhere in the middle. So it's easier to see, I suppose. No reason whatsoever. So now how much does that cost me? Well, simply the number of rooms that I'm short times the cost here, which I'll fix. And we can drag that down to just see that it changes whenever I have something short, and I can very easily verify that the cost is what it should be. Now, this isn't the only way to do it. There are variations, but I think for a start into this use of Excel with simulation, the if statement is solid. There's nothing wrong with it. But there are alternatives, like you can look at a maximum and things like that. But I think this is good enough for now to get us into how the logic works behind the scenes. The if statement shows that very nicely. It doesn't have to be the shortest formula that I can come up with, right? Sometimes something longer shows the thinking, the process behind it nicely. Okay, so next up we have to figure out, do we have any vacant rooms? When are we going to have vacant rooms? Well, it really depends on if I'm short, I won't have any vacant rooms, right? Or another way of saying it, if the no-shows are less than or equal to 3, my room's overbooked, 3, then I'm sometimes moving people to other hotels, but I'm not vacant in any way. But when that doesn't happen, I have no-shows 4 and 5, then I have some vacant rooms. So it seems to me a good starting point is to go with an if statement again, or an if function rather. So let's go over here maybe like that. So my test in this case, I want to see, when do I have a vacant room? If the no-shows are greater than the rooms I've overbooked, like 4 or 5. Now I know I learned my lesson. I'm going to fix that overbooked cell. We'll show the formula in a second. I know that in this formula input window, the text is kind of small sometimes. So I'm checking to see, is the no-shows greater than 3 essentially? If it is, that means I have vacant rooms. And I should take the no-show number, subtract from that the 3. If the no-shows weren't that many, then I have 0 vacant rooms. Now, we'll copy that down a little bit to see some variety. Ooh, I see I get weird numbers, right? Let's see what happened. Originally, in my subtraction here, the pink cell, the 3, should stay fixed. So I can easily spot that, go back, do it again, run a few times, and then we'll see. Okay, let's see some variety here, like this. If I have 4 no-shows, there's 1 vacant room. Exactly, because it cuts out the 3 I overbooked and another 1. If I have 3 no-shows, then perfect. The rooms I overbooked fits perfectly, and I'm completely full. 0 no-shows. Now those 3 people have to go somewhere else, and that's covered here in the short rooms. There's 0 vacancies. 1, 5, I'm going to have 2 vacant rooms, nothing short. So this seems to be good. Then the vacant cost, very similar to before, the number of vacant rooms I have times my cost of having that room vacant, that I will fix, of course. I'll copy that down, and we are pretty much done. then the total cost is simply the short cost plus the vacant cost. Easy peasy. Generate a few, see if everything looks pretty good. You can visually check most of it. Looks pretty good. Okay, so now I check back my question. Says simulate 1 month. Simulate 1 month, 30 days of operation to calculate the hotel's total monthly cost due to overbooking and opportunity cost. Not total, average. You can calculate the total. Oh, sorry, this is the total. The average total cost per day. Right. So we want to copy this down to 30, which will be roughly at row 34. Oh, I went one too far. Let's delete that guy. Beautiful. 30 days. And then I can put it into this green cell here, simply the average, and I'll select all the total costs daily, average daily total cost, oopsie, bracket, is 161. And you see, of course, as I recalculate, it changes quite a lot. $30 difference. There I go down to 125, up to 38, back down 45. So there's quite a bit of fluctuation here. Oh, 100. Whew. Quite a bit of fluctuation. So that was an 87. Wow, that was low. So there's some randomness, of course, happening here. So do I trust that 132 to be a good representative number? Do I trust that 101? No, the variations are too big, right? How do I fix that? Well, this is one run of the simulation. Every time I recalculate, it's one run of the simulation. There's another run. I want to repeat this 200 times to get a much more stable, much better representation of the actual average daily cost. So I'm going to do this by way of a data table because I have no space. All of this space was used to generate one run of the simulation. So I'll have my data table over here. Let's say data table. Let's call this run. And let's call this average. Let's just say cost. So I'm going to do this 1, 2, 3, all the way down to 200, because that's what they want. 200 is a nice number. It's not ideal. More is better. But if I go too far, then Excel slows down a little bit to calculate all those things quickly. So just to prove the point, 200 is sufficient for us. Just to illustrate this, I like to color this guy green because it's sort of an output formula calculation cell. I want to just calculate, I want to recalculate the whole spreadsheet and then return the average daily cost. Okay, so for the data table, for my purposes, I need a temporary dummy cell that no one uses. That's going to be my blue cell over there. So in truth, the data table does put this number in the run column into that blue cell, imagining it actually has an effect, which we don't want it to have an effect, recalculate everything and return the output cell that I want. I select the whole data table, just like the previous example. And then I like to go, maybe I should have done it from the bottom up. Oh, whatever. Data, what if analysis, data table. Oh, it's so tiny. I'm looking at columns, and my blue cell is the dummy input cell. Okay, calculate. Oh, it does not copy the green for me. Oh, that's unfortunate. I want to make it look good. Not that it actually matters, but hey, I want to do it. Let's make it a nice green. Beautiful. So now I could say here, based on 200 replications or runs, whatever, my average daily cost is going to be, let's make it green, the average of all these data table values. Much more stable result if I repeat the simulation. That's the whole point of simulation, right? Something that I can repeat over and over and over. So now compare these two when I recalculate. See, it's already, you can see here at the bottom, Excel is taking a little under a second, but taking some time to recalculate all of this 200 times, right? So you see the bottom number does not fluctuate by much at all. So pick any one of those and it's giving you a fairly good representation of what is happening here. The more runs I do, of course, the closer this is going to be to the hidden theoretical expected value. That in more complicated situations is really hard to calculate, especially when I'm using different distributions and all kinds of stuff. All right. So that is the first part. Good. Now, part number 4. No, not question 4, part B here. Let's zoom in on that. Okay. Heartbreak Hotel would like to determine the most desirable number of rooms to overbook. Currently we're at 3, but who says that that is a good idea? Who says that that is the best? They want to test, should they overbook 0 rooms? 1, 2, 3, 4, 5? Currently, our simulation is doing 3. But we want to figure out which is actually the best. What can we recommend and how do we figure it out? Now, in the basic way, what we could do is we could say rooms overbooked. Let's say that is, how should we do it? We'll number it over here. 0, 1, 2, 3, 4. Ooh, I'm out of space. Okay, let's go columns then. That's fine. Space is an issue. Rooms overbooked. Let's make that a little bigger. There we go. Versus the daily, whoopsie, cannot spell, cost. Why is that not bold? So here, we are going to have to figure out something. Let's make it green. It's not really an output. No, let's not do that. So what we could do is we already have a good number for 3. That's what we've been doing. So, I mean, you don't know which one to pick, right? There is some fluctuation. I close my eyes, I press it a few times, whatever I get, I get. It's a little high, but whatever. 128.45. It's as good as any other. If I have more than 200 repetitions of the simulation run, or more than 200 simulation runs, rather, then the number would fluctuate very little. So, but then we would have to wait a few seconds for Excel to do it every time. So for the purposes of this example, I don't want to do that. So then we can go and say, okay, well, let's change this rooms overbooked number to 0. And then do everything again. Recalculate, 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 recalculate. Still get a pretty stable number. I close my eyes, I press it a few times. What I get is what I get. 126.05, for example. And then I can change that to a 1. recalculate, 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 recalculate. Oh dear, that's a quite low cost, right? 93.16. It's way better. And then I can change it to a 2 and do it again. Recalculate a few times until I get... Oh, that was randomly very low. Oh, no, actually not. 84.67, for example. And then I already did 3, so I'll do 4. Recalculate, recalculate, recalculate. 200, really, that is a extreme outlier, that one. Oh, no, it was not. I see. I was looking at the previous numbers. Wow, that is high. I thought I was still in the 90s. No, that is way more. So if I overbook 4 rooms, that is very costly. If I overbook 5, look at that number, recalculate, recalculate, recalculate. Ooh, that's even worse. Oh, wow. That is high. Come on. No, really? Now 300 suddenly? Why does it jump? It was in the 260s for the longest time. All right, whatever you say. 308.85. Okay, let me just do 4 again. Just curious. Okay. Good. And we see that if we change the rooms to 4, for example, if we have some no-shows here, most of the times I won't have any vacant rooms, right? So I have some rooms short more often, and that's much more costly than having vacant rooms. So it kind of does make sense that too many rooms overbooked, and I increase my cost. However, 0, if I don't overbook any rooms, that is not the best. Yeah, so based on this, I can then make the recommendation that it seems to be 2 rooms overbooked is the best choice. So nothing wrong with this. This is what you would have to do, right? You would have to test the different parameters and see how it affects your measure, in this case, the daily cost. However, it's a little tedious. We can automate that a little bit with Excel. And the way we do that is the scenario manager. So we click on the data tab. We click on what if analysis, because it's so appropriately named. What if the rooms overbooked were different numbers? Scenario manager is what we're going to do. So we want to create a scenario for each of these. So we're going to add one, and let's call the first one 0 rooms overbooked. I'm just going to highlight this so I don't have to type it every single time. So I'm going to change, my changing cells will be, get rid of that, will be the daily cost. And I'm going to say, okay, no, why? Don't be like that. Oh, I have to actually, oh, sorry. Let me just go back here. Cancel that. Let's add it again. Sorry, I clicked on the wrong thing. 0 rooms overbooked. My changing cell is where Excel should put the number 0. It's in the rooms overbooked. Good. Then what value should it put in there? My 0. Then I'm going to add another one. It's 1 room overbooked. Or room. Changing cell, is it still K12? Yes, it is. Okay. It should put in the number 1 there. and I add the scenario for each one. Next one is 2 rooms overbooked. Check the changing cell. It should put the number 2 there. Add another one. 3 rooms overbooked. Changing cells good. Put the number 3 there. And 4 rooms overbooked. Changing cell is where it should put the 4. 4. And one more. 5 rooms overbooked. It should put a 5 in the changing cell. Okay. Good. Then we're going to click on Summary. And it needs to know, well, what is the result that I'm trying to actually summarize? Well, it's the daily cost, right? It's this cell K21. Okay. And it puts the results in a new tab for me. But I see something weird happened. I did it on purpose. I know. Something weird happened. It's all the same. For the scenario manager, I need to go back and change the formula calculation to automatic again. Unfortunately. So I'm going to have to delete this. It's garbage. And do it again. However, it's not that bad. Data. What if analysis scenario manager? It remembers everything I did. So not that bad. Summary. Output, or yeah, keep track of that average daily cost from 200 runs. Go, do your thing. It's going to take a while, right? It needs to run this quite a bit, which is completely understandable. But it didn't take that long. And then we see, okay, I don't care about the column D. I care about these guys. It made it nice and purple. It's nice. I can format this if I want to. So it got 125, 94, 83. It just did it once, just like we did. So the numbers aren't going to be exactly the same as ours. But how does it compare? Number 3 here. Let me just copy this over so I can have it on the same sheet here and just do a comparison. So 0, very similar. 1 room, very similar. 2 rooms, very similar. 3 rooms, very similar, very similar, very similar. And we can then say, okay, the optimal number of rooms to overbook is 2. Why? Because it gives me the lowest average daily cost. Let's write that down. So whether I do it by hand or whether I use a scenario manager, it is up to you. The recommended number of overbooked rooms is 2, since that will result in the lowest average daily cost. There we go. So a couple of things, couple of options. You can do it yourself. You can run Scenario Manager if you do Scenario Manager. Just be sure that you turn your formula calculation in options back to automatic. But I'm done, so let's maybe turn it back to manual for the next simulation we're gonna do. All right, that is the end of our example. Quite a lot of nice things. Have a look at that and let me know if you have any questions. Until next time.